Now, to lift this 840-pound machine, I had planned to use my shop crane, which I use for removing engines from cars, but while it has the height, the legs simply aren't wide enough to go around the base of the machine, let alone the pallet itself. So what to do? Now, I realize this looks super sketchy, and I don't recommend you do what I do, but what we did was to shim the whole lift up on top of the pallet so that we could then slowly remove the pallet out from underneath it. And how am I going to get the pallet out from underneath it once the lift is on top of it? Why, with a Sawzall, of course. Sound dubious? Watch. First, we'll lift the machine to rock it back and be able to get underneath the front, which will allow me to remove some of the pallet from the front wheels. And just as you can carve an elephant by taking a rock and removing everything that's not an elephant, I'm just removing everything that's not PDP-11 here, and slowly all we'll be left with is a computer hanging from a strap. And with the PDP-11 suspended in midair, I can now let it down. We'll pull out the final board from underneath the one wheel, and we should be ready to go. And finally, I'll remove the strap, back to lift away. Glenn will do a little pass with the vacuum, and we've got a brand new 1134 to start troubleshooting. Hey, I'm Dave. Welcome to my shop. I've always wanted a PDP-11 mini computer. When I was a kid, they were state-of-the-art, and by the time I was in college, they were a staple of our CS program. I tried to scratch the itch with a PDP-11, which is a thing of beauty in its own right, but somehow emulation just wasn't doing it for me. I wanted a real PDP-11. And that's when a viewer named Mark Pappin offered to donate a micro PDP-1173 to the channel for the price of shipping. Of course, I eagerly said yes, and when it arrived, I fixed it up and got it working again. A little later, thanks to some help from David over at Usagi Electric, I was also able to get this PDP-1123 up and running, which is actually upgraded to 1173 CPU specs. It's the one I actually used to demo RSX-11M for Dave Cutler when he stopped by for his interview. And if you haven't seen the Dave C interview, be sure to check it out next. At least now I had a real deck PDP-11, but somehow what I really longed for was an older vintage. Something big iron where it's a full rack of equipment with an entire compute drawer full of discrete logic. Ideally with lots of dust blinking lights. And that's when I found somebody who had two PDP-1170 front panels for sale. Now, the classic 1170 panel is what the PDP-11 is modeled after, but the last time I saw a full 1170 system for sale was never, so I was glad to just get the panels even. But how to make them work? Well, it turns out there's a PCB setup from Jorga Hopka at retrocmp.com known as the Blinkenbone, and it allows you to run a fully emulated PDP-11 on a Raspberry Pi, and then it connects the internal emulator state to the 56 or so LEDs on a real 1170 control panel. And you can still halt the processor, toggle in data, and everything functions just as it should. I thought I finally had it all, but then I was surfing eBay one day, and you know the drill. That thing you've been waiting for all your life suddenly pops up. A full stack PDP-1134 with 3 hard drives being auctioned off, and the proceeds going to charity. How could I say no? Well, I didn't say no. I sniped it. Someone else was also trying at the last second, but my bid was the winner at $4,494. Not cheap to be sure, but it looked like an amazing system. Make sure you subscribe to the channel since I don't really do sponsorships and it's views that pay for this stuff. So while we're waiting for the PDP to arrive, let's take a minute to take a brief tour of the PDP-11's rather amazing history. It all started with Ken Olsen, the co-founder of Digital Equipment Corporation, or DEC, who had a vision of creating smaller, more affordable computers. In the late 1950s, when mainframes were the size of rooms and cost millions of dollars, DEC sought to break the mold. They introduced the PDP-1 in 1960, a machine that was compact and only cost about $120,000. A hefty sum to be sure, but a mere fraction of the cost of its competitors. DEC continued to innovate, releasing several models in the PDP series, each more advanced than the last. The PDP-8, launched in 1965, was particularly revolutionary. It was small, affordable, and incredibly popular, making it the first mini-computer to gain widespread use. And by the way, the term mini-computer is a little bit of a misnomer. They're only mini when compared to massive mainframe installations, because even a single PDP installation could fill a small data room or data center with disk drives and tape readers and consoles and multiple cabinets and so on. And next came the PDP-11. Launched in 1970, the PDP-11 was designed to be powerful yet simple to use. It featured the innovative Unibus system, which made it easier to connect peripheral devices. Each device in the system can see the bus, including the full memory map, and then read and write directly to and from memory, even using DMA. This flexibility, along with its powerful 16-bit architecture, quickly made the PDP-11 a favorite among engineers and scientists. The PDP-11 series saw numerous models over its 20-year lifespan, each building on the success of the previous ones. The early PDP-11-20 set the stage, followed by the more powerful PDP-11-34 and the 45, and the incredibly versatile PDP-11-70, which became the icon of the series. The PDP-1170 was the epitome of the big iron mini-computer with its impressive blinking lights and control panel that enthusiasts like me adore. The PDP-11's influence didn't stop with its hardware. It ran several notable operating systems, including RSX-11, RT-11, and Unix, the very first version of which was initially developed on a PDP-1120. The versatility and power of the PDP-11 made it a crucial part of computer history, influencing the design of later computer architectures and operating systems. And that brings us to my own PDP-1134, which eventually arrived on a liftgate truck. The driver wheeled it into my shop and dropped it into an empty stall, and the adventure begins. Now, I actually opened with the footage of us offloading it from the pallet, but here's how it looked when it arrived. The machine arrived in apparently good order, packed with cardboard and styrofoam. I probably would have preferred a wooden crate, but you take what you can get. You'll notice underneath there is a plywood plank about a 1/4 inch thick. That will come back to be of interest later. This would be my first time to actually handle and operate a DEC PDP-11 because up till this point in my life it's always been done by data operators or the college administrators or whoever owns the machine. But now I own the machine and I can do with it as I like. Upon closer inspection, it had actually crushed the broken pallet on which it was delivered. According to the shipping manifest, this machine weighs more than 800 pounds. What I didn't know was that the machine also had a nice set of steel casters under it, except either due to weight or shock or some combination thereof, the wheels had punched right through the plywood base that they had set it on, so it looked like the whole thing was sitting directly on the frame. Once we had it unpacked, I did what Dave would do. I rolled a VT220 terminal over to it, then prepared to plug it in and turn it on. I had nowhere to plug it in at first because while the tag on the machine says it's 120 volts at 24 amps single phase, the machine has a NEMA 30 amp twist lock connector for a power cable. I do have a 30 amp 240 welder outlet that I can adapt as a more permanent solution, but for today I used a NEMA adapter to step it down to a 20 amp plug and figured I'd take my chances. Worst case, I'm monitoring it and it would trip the breaker. When I plugged it in and I turned it on, I could immediately see that it only pulled 929 watts at idle. Only. So for now at least I was okay. The machine was definitely not okay, however, because as soon as I powered it up, it started making a horrible sound. So I grabbed the power cord, plugged it in, and for a few seconds, all seemed well. And then... panic! I couldn't tell if it was an electrical arcing sound or perhaps a big metal fan rubbing on the chassis, but either way, it wasn't good. Worse, the display on the PDP was flashing in time to the sound, so it was definitely something related to the power circuit. I unplugged all the loads from the power distribution box so they wouldn't suffer, and I tried it again, but I got the same result. I pulled the power box out of the chassis and opened it up, and long story short, it turns out that the power contactor was cycling. The contactor is a huge magnetically triggered on-off switch that controls the entire cabinet. The power box monitors the incoming line power and the switch state, and when the switch goes on, it engages the contactor to power up the rack. Except as soon as it was engaging it, it was then killing it and repeating it in a cycle at a rapid pace. Definitely not good for anything connected to it. I posted on the PDP-11 Facebook group, and somebody chimed in with the actual number of the capacitor that I had to replace in order to fix this problem. Sure enough, I replaced that one cap and the power system magically worked. I can't overstate how helpful the PDP-11 Facebook group has been, with a few members in particular, like Ethan Dix, holding my hand and walking me through the various mysterious processes that I would encounter along my PDP-11 journey. I couldn't have done this without them. Mark Matlock has also been super helpful along the way. Not everybody was as universally helpful, though. A few members took significant exception to my cowboy attitude, where I would test things to see what worked rather than methodically inspecting and bench testing each subcomponent in order to make sure that I didn't just destroy the thing. I was called unethical for risking this rare hardware to my YOLO approach. Now, I don't know about unethical, but they're not wrong. That's because likely that's the right way to do it. But it's just not how I roll, especially when you're trying to make an episode a week here. I can't really afford to spend a month on an episode, and more importantly, my approach has served me pretty well so far. I have a rather extensive collection of vintage hardware, and I take significant pride in that everything boots and works and is not just for display. Sure, I grenade the occasional thing with my wanton disregard for its historical importance, but then I fix it. And yet my Kim 1 still has the original white chips after all, so it can't be that bad. So enough navel-gazing. What happened when I plugged it in and turned it on? Flames? Smoke? Not at all. In fact, it booted right up to the bootstrap prompt. So far, it was 100% operational. It was a huge relief to know that the machine I'd bought had at least worked this far. Unlike the even older models where you might have to toggle a bootloader program in through the front panel, or more likely load one from paper tape, the PDP-11 34 has a bootstrap ROM that can boot off of a range of devices. The only problem was that everything I tried just hung. My string of unbroken successes had finally come to an end, so perhaps it was time to get a bit more methodical. My next step was something I really should have done first, and that was to replace all of the air filtration in the system. On the back of each drawer is an intake fan with a pre-filter, and each of them was so old they just turned to dust when you looked at them. On the bottom panel of each unit is a filter that lives with the I/O cards in the chassis, and they were similarly degraded. Under each of the drives is a large and efficient HEPA filter for which no replacements exist, and you're unlikely to find an NOS unused digital unit these days. So I removed each one, and I did something else that I would be chastised for, rightly, blowing compressed air through the filters. It turns out that these are what are known as absolute filters, and blowing them out or attempting to backwash them can just drive particulates further into the filter material, potentially plugging them up. Fortunately, all of mine retained good airflow, and they looked like they were fairly new at the time. Next, I replaced the pre-filter foam on the intake grill at the back of each of the hard drives. I ordered aquarium filter foam, and I cut rectangular blocks to match the pieces on the bottom trays, as well as round pieces for the intakes on the blower fans that live inside each of the drives. I used a round template to cut new pieces that I inserted between the fan and the I/O cage. Now that blower fan goes through a big HEPA filter and then discharges directly into the disc pack. The seal between the disc pack and the discharge nozzle was also petrified, and as soon as the disc pack was removed, its mortal remains started to go everywhere, so a thorough cleaning was now in order. I think it's an urban legend that this airflow is required to float the heads, as I think it has much more to do with cooling. Either way, proper clean airflow is essential to the lifespan of the drive. So I replaced the duct seal with strips of rubberized weather stripping and then bolted the nozzle back into place. Next up was to figure out why I was unable to boot from the drives. I had noticed that the ready and on cylinder lights never illuminated, and from my understanding they should do so independently of whether the CPU is using and talking to them or not. But since they weren't lighting, it was time to dig a little deeper. Someone on the forum suggested that the heads might be locked for shipment. I dug out the RK05 manual to understand precisely what that means, and it turns out that when you're shipping the drive, you should literally bolt the heads in place with a mechanical stop so that they can never contact the disk surface. And sure enough, when I looked at the enormous motor that controls the heads, the head stop was indeed in place in each of them. Now this is actually a great thing, as it means whoever retired this system took the time to do it right. It wasn't just turned off and thrown on a truck, at least. It could also account for why I was unable to boot, so I went through each of the drives and carefully removed the head stop, turned it 180 degrees so that it was clear of the heads, and then tightened it back up. The heads were now free to roam. And sure enough, as soon as I powered the machine back up, I got a ready and on-sill light on each of the drives. It was some progress. While I had the drives open again, I decided to find and replace the NiCad battery pack installed in each unit. These batteries are used to retract the heads if the power goes out. You never want the heads to just settle on the disk surface due to a power failure. Now, the battery packs weren't original, but they were pretty clearly of a very old vintage and long past their service life. I cut the wires to each, leaving myself as much slack as possible, but that amounts to just a couple of inches, particularly on the negative wire at the back of the drive. You don't want to make too many mistakes when you're stripping the insulation back on this one. For each one, I then soldered in a new NiCad's 4-cell pack that I found on Amazon. In one drive, as soon as I connected the battery pack, the heads went wham and retracted with great force. I'm glad I didn't have any fingers in the way. It's a powerful mechanism. With all the battery packs replaced, I buttoned the system back up and powered it on. Unfortunately, there was still no sign of the CPU even being able to see the drives, so it was on to the next step, the connections between the CPU drawer and then the individual drives. It's actually a pretty cool system. There's an extension cable that plugs into one of the main backplane slots, and as I understand it, that cable carries the parts of the Unibus that are important to I/O devices. That cable plugs into the first hard drive, and then a second cable daisy chains from the first drive to the second, and then from the second to the third. It's elegance personified if somewhat held back by a large and fragile external ribbon cable. Coming out of the back of that last drive, though, in my case, was an 8-foot bus extension cable. In the PC world, timings are just way too fast and precise for the PCIe bus to be pushed that far, but in the olden days of slower clock speeds, you could extend the bus into a second and third cabinet and even beyond. In fact, you can go up to an impressive 50 feet in total length. And this 8-foot cable of mine was clearly intended to connect into a second cabinet, likely with more drives than the floppy drives that weren't connected to my machine. A cabinet that wasn't part of the auction and that likely was sold separately, and that was a problem. It's a problem because the very last device in the chain needs to be terminated, much like a SCSI drive from the 1990s. That means you have to install a special Terminator card that contains a resistor pack that pulls all of the signals on the bus down to ground on the very last device. Mine was no doubt in the missing cabinet, but it's required for the drives to operate, otherwise all the lines float on the bus, and so I found and ordered a replacement on eBay. When it arrived, I eagerly unpacked it and went to install it in the top drive, which is the last one in the chain. To do so, I removed the cable extension that was coming out of the drive's I/O cage and replaced it with the Terminator. It's a bit of a bear to sneak it in there, but I managed to get it installed. Now that I could ostensibly communicate with the drives, I tried booting again, but to no avail. It was time for some diagnostics. Unfortunately, DEC made a very comprehensive set of tests for all aspects of the machine, including the RK11 controller and my RK05 drives. I did, however, face something of a chicken and egg situation, as with no hard drives and no floppy or tape reader, how would I even get the diagnostics onto the machine? Jörg Hoppe, or as I call him, George Hoppy, has an amazing site dedicated to the PDP-11 where he offers a ton of technical documents, all the diagnostics, and even software and hardware solutions essential to maintaining a PDP-11 system. Perhaps the most important of these is a program called PDP-11 GUI. You connect the PC to the PDP-11 over a 9600 baud serial link, at which point it can talk directly to the 1134 boot monitor, poking values and even entire programs into memory and then running them as needed. The first thing I did was to run the built-in memory test. Let's have a look. To test the memory, we'll use a built-in feature of the PDP-11 GUI program. It's going to test all the data lines by reading and writing memory addresses at various points in the memory, and then we'll test the address lines and we'll test the data bits all one by one, and fortunately everything is going to pass, which is actually really great news because it's never clear when you get a machine this old how much of the MOS memory is going to be surviving at this point, but so far it looks like everything's good. It was both fortunate and reassuring that all of the memory tests and CPU tests passed. And that brought me to the big moment, the RK05 disk test. Now to run the low-level formatter, we actually boot into a diagnostic program called XXDP+. We then run zrkifo.bin, which is the disk and controller test package. We'll select type 1, which will do a basic compatibility test on all of the drives. We'll give it a list of drives that we're actually interested in testing here, but we'll just test the 4th drive. That's the removable pack. To remove the pack, you have to hit the load button, wait about 20 seconds, and then we can remove the entire deck pack cartridge. Then I'll load this spare pack in and we can do our testing and formatting on this spare pack and see how that goes. With the pack installed, we simply close the door and hit the load button on the panel, and that should be all that it takes. We'll tell the system we want drive 4, and there's no second system available. We'll mount the pack, and then we'll press continue to run the test. And unfortunately, data written by the drive cannot be read back. Can't tell at this point if it's a problem with the drive, a problem with the controller, or a problem with the disk pack, but given that I'm getting errors on all 3, I'm going to assume that it's probably a controller issue, just a guess at this point. Sadly, now that I could see that I couldn't reliably read from the drives, I pretty much abandoned any hope of recovering what was on them. But unless it was just going to magically boot from them, it wasn't that big a deal anyway, so the fact that the disk test I just ran was likely destructive doesn't matter in the end. It just honestly wasn't that important. I also want the flexibility to run multiple different operating systems, from RT11 to RSX11 and the original Unix. And the reality is that even 3 RK05 drives isn't really big enough to hold very much. And that's where Jörg Hoppe enters the picture again with his amazing Unone product. This isn't a sponsored episode. I bought this Unone and its Unone Twin that you can find in my 1173 with my own money. And they'd be a deal at twice the price because it's a card that plugs into the Unibus slot and that can emulate a range of important Unibus devices, from system memory on down through a multitude of storage types. The Unibone is billed as a Linux to Unibus bridge because it actually contains a BeagleBone Black Linux computer. That computer has access to the Unibus, and so it gives the Unibone the ability to present devices on the bus. To that end, you can mount a disk image file under Linux and have that show up as a PDP-11 drive. There's even a shared folder set up where you can share a disk folder between the RT11 side and the Linux side and transfer files back and forth and so on. I'd actually ordered my Unibone the same day that I ordered the PDP-11, knowing that I'd likely need and want one. I prepped the SD card with the images I want to run and installed the card, and the machine would not boot. Eventually, with some tinkering and rearranging of cards, I was able to get the machine to at least boot, but the Unibone itself couldn't interact with the rest of the system for some reason. And that's where the scary and ugly notion of grant lines enters the picture. You see, the Unibus has a series of signals that go on the bus from one slot to the next, giving each card in the stack a chance to intercept and handle that signal. A good example is the NPG, or non-processor grant line. It's used to allow a device to take over the bus and modify memory directly through DMA. The CPU passes that signal out when DMA is valid to occur, and any device can intercept that signal, do its DMA, and then not pass the signal on to the next card. So it's a priority order in who's first in the bus. If the card doesn't have any DMA requests, it passes the signal on to the next card. The Unibone fully handles the NPG line, but to do so it needs to be in a slot that doesn't have it bridged across the slot, because it needs to be able to selectively pass that signal along. If it's hardwired underneath the slot, it's beyond the control of the card. The problem is that this requires every card to have some logic, or at least some trivial wiring, to propagate that signal from one slot to the next. And the tragic reality is that since cards were not required to have it, most do not. And so as a solution, the NPG grant line is often hardwired from one slot to the next. You can see in this diagram the dotted lines that carry the signal, and in this case, dotted line means undefined. The only way to know which slots are bridged like this is to check the continuity manually. To be able to do so, it was time to remove all of the cards so I could get in there and test each slot's NPG in and out pins. Here we go. My first step is to remove all the boards that comprise the disk controller. There's actually 4. And then we'll get on, and it is a floppy controller will come next. You'll see a cable coming out of that. There you go. And for each card that has connections like this, they're actually fortunately labeled, so I will just remove them and let them dangle for now. This next card is called a decade card, which I'm guessing is a DEC analog to digital converter. It has a lot of inputs and outputs, but I'm not certain. Here we have a serial console card with this cable that runs out to a DB25. At the end of the bus, there's always a Terminator, which I've removed and set aside, then the I/O cable, and this bridge between the two backplanes. And here you can see the set of boards that I removed from the machine. On the far left are the 2 boards that comprise the actual CPU of the system. It's all discrete logic, probably some bit slice ALUs, and who knows what else, but it's rather pretty to look at. The next card we have up is the decade card that I mentioned, the DEC analog to digital converter, or at least I presume that's what it is. I don't have any docs on that one yet, so it's hard to say. This is the memory board. This board contains probably 256K of MOS memory. On the far right are the 4 boards that in discrete logic make up the disk controller, and the one here with all the blue dip switches is the serial board. Next, with all the cards removed, I was able to test which slots are bridged and which slots are open. It's a matter of checking pins CA1 to CB1, and if those pins are joined, then you know that they're bridged underneath. I got a long set of skinny probes for my multimeter and had at it. It turns out that in my case, the first 9 slots are all hardwire bridged. The last 3 slots in the RK11 bus expander are not bridged, but the disk controller lives there, and I wasn't about to remove it to make room for the Unibone. And that meant there was only one solution. Cut the grant line of one of the first 9 slots so that I could install the Unibone in that slot. Now, to be honest, I was more than a little terrified at the prospect. Looking underneath the backplane at the wire wrap side, you can see 1,944 pins, all wire wrapped to little posts. Somewhere in this mess was the wire that I needed to cut. I could only hope that it'd be blue.
What do you mean, cut the blue wire? They're all blue wires!
I pulled out the CPU drawer and crawled under so I could get access to the Unibus backplane underneath in the hopes of finding the right wire, and even with my reading glasses, found it was too close to my face to be able to see anything. So I grabbed a magnifying glass and was finally able to see the 2 pins that I thought it should be. I checked with the meter and they were indeed connected, a good sign. Next, I found a small wire wrap jumper between the 2 posts, and I carefully used a screwdriver to lift it off one of the posts. If I knew how to wire wrap it, I'd unwrap it, but I don't know how to wire wrap. I left out the spare serial card from slot 9, which is where I had cut the MPG grant line, and I installed the Unibone card there. Alright, we'll do a little flyover of the boards here before I put them all back. I've aligned them in the order that they need to go back into the system, and that should make things a little simpler for me. Okay, right now we just have the CPU and the programmer's panel installed in the system. We're going to install the rest of the cards now. We'll start with the memory board, which is 256K. And once that's snapped into place with the nice metal mechanism that it has on these longer cards, which I really like, I'll get my map to see where everything else goes. Let's see which goes next. This one looks like it goes next. And then the floppy control. Oh, no, wait. Serial port, probably. Yep, serial port. There we go. We'll plug the serial port in. We'll slide the decade card back home. And then next in goes the floppy controller. And that should bring us to the disk controller. Board 1, board 2, board 3, and board 4. And that should be everything. At this point, I figured there was a 60% chance that I was either barking up the wrong tree with my idea, or I had cut the wrong wire, and then I'd probably rendered my machine inert. But hoping against hope, I powered it up. And lo and behold, the machine sprang to life, and the CPU controls on the front panel seemed to operate correctly, so it really seemed like the MPG grant chain was working properly. I connected to the Unone's Linux installation via SSH and mounted an RT11 disk image in a way that should, in theory, allow the PDP-11 to boot from it if the Unone and DMA was all working properly. I crossed my fingers, hit the initialization button, and waited a few seconds. The system was alive, but would it boot? Well, to boot off a drive, you do two things. First, from the Unone side, you load a bootloader for the particular type of device into the Unibus memory. And then on the PDP-11 side, you start execution at the memory address where you loaded the bootloader, and it should in theory attempt to boot from the drive in question. And here's what happened when I finally gave it a try. Okay, if everything has gone according to plan, the machine should be booted into RT11. I'll go up and press enter, and yes, we get a prompt. And if I type dir, magically, we get a listing. So the system is up and running, RT11 operating system. And I probably need to turn on flow control on the terminal so it doesn't garble like that, but otherwise it seems to be working perfectly. And there you have it, the PDP-11's journey all the way from eBay back to running a vintage operating system. I've also installed RSX11M on it, and I'd love to do more content on a PDP-11, so if there's an audience for it, please leave me a shout in the comments as to what you'd like to see me do with it. And no, it can't run Doom. If you've ever wondered if you might have some characteristics that place you somewhere on the autism spectrum, check out the free sample of my book on Amazon, The Non-Visible Part of the Spectrum. It's intended for folks that likely don't have ASD, but who share some traits with the spectrum. It's everything I know now about living a successful life on the spectrum that I wish I'd known long ago. If you found today's little PDP adventure to be any combination of informative or entertaining, please remember I'm mostly in this for the subs and likes, so I'd be honored if you'd consider leaving me one of each before you go today. And if you're a PDP-11 fan, please be sure to check out my interview with Dave Cutler. In the meantime and in between time, I hope to see you next time, right here in Dave's Garage.